Okay, on this video, we are going to continue with the EOC practice test questions, and we will begin on question number 11. So if we go to number 11, it says, given the equation C of H equals 15H plus 6,300, create a scenario to discuss what each number and letter represent. So I'm going to start out with $6,300 in my savings account. So 6,300 is your starting amount. 15H, I make $15 an hour at a job. So 15 is dollars per hour. H is how many hours you work. So 15H plus 6,300 is equal to C of H. That tells you how much money you currently have. So how much money you have. All right, now we're going to come over here and we're going to find number 12, which I think is right about here. I'm sorry, number 11. And yes, it is. It's right here. So a company manufactures handband, a wireless activity tracker. There are initial setup costs, startup costs involved. Additionally, the company spends a certain amount of money to manufacture each handband. The cost of manufacturing H handbands is given by the function C of H equals 21H plus 1500. So H is the number of handbands. And you guys can write it in the box down here where it's supposed to be. I just want to make sure I have enough room to do it. So H is the number of handbands. These are startup costs. Okay, it costs them this much money to start it up. And it's given by the function C of H equals 21H plus 15,000. So if you come down here and you look at your choices, the company earns $21 profit for each handband they sell. You can eliminate that because we know we're talking about cost, not profit. The company spends $36,000 to manufacture 1,000 handbands. So I'm going to take 1,000 and plug it in for H and see if that is correct. So 21 times 1,000 plus 15,000. 21 times 1,000 is 21,000 plus 15,000. That does equal 36,000. So the company does spend $36,000 to manufacture 1,000 handbands. So your answer is B. Again, C just talks about the startup costs. This wasn't, it says this is the cost of manufacturing H handbands. So it's not the startup cost. Oh, I do not know what I just did. And I don't know how to get rid of it. Sorry, guys, this is a new program I'm trying here. So the startup cost, that's not it. You can eliminate that. And then again, CH represents the revenue the company receives. Revenue receives. We know we're talking about startup costs. So that's how much it costs. It's not profit or money that they're getting in there. So you can eliminate D. B is your answer for that one. We're going to go back here now and we're going to do number 12. They want us to find an ordered pair to solve this equation. So when I look at this, I see 3x minus 5y. You could draw your upside down t if you wanted to. So that way, you know, if you're trying to get rid of this negative 12, the easiest way for me to get, well, that's one way. That's one way to solve for one of the numbers. So I can look at this and I can see I have 3x. If I multiply 3 by -4, then I get another -12, and then I know I'm going to add on both sides to get rid of it. So that will get it to 0. So 3 times -4 is -12. Bring down your -5y equals -12. Add 12 to both sides. That cancels out. You get -5y is equal to 0. Divide both sides by -5. You get y is equal to 0. So when x was -4, suddenly my pen has decided it doesn't want to work. When x is -4, y is 0. And that is your ordered pair. So we're going to come back over here to number 12. And it says it wants us to identify the values that create an ordered pair that is a solution to the equation 3 of x minus 5y equals 20. So for the first one, they have x is 5, y is, and you would have to find y1. So if I start with A, they have y1 is listed as 1. So plug in 1 for y and see if this makes a true statement. So 3 times 5, because they say here 5 is, or x is 5. 3 times 5 minus 5 times 1 equals 20. 3 times 5 is 15. -5 times 1 is -5. 15 minus 5 does not equal 20. So you can eliminate A. You then can also eliminate B because B also has y as 1 in the first one. If it's not true the first time we did it, it's not going to be true the second time we did it. So we can eliminate B. All right, now we can take -1 and plug it in for y. So we have 3 times 5. Again, we're still using this 5 here. 3 times 5 minus 5 times -1 equals 20. 3 times 5 is 15. -5 times -1 is +5. 15 plus 5 does equal 20, so that is a true statement. Your answer is C. We could continue to the next one. We know, just to double check and make sure that that's not an answer. So we know -1 is correct. We don't have to check that. But now where it says x2, we want to plug that in for x and solve. They give us y is 2 and see if that comes out to be a true statement. So we have 3 times -10 now minus 5 times 2 equals 20. 3 times -10 is -30. Minus 10 equals 20. -30 minus 10 is -40, not -20. So that does not equal 20. So D is not an option. Let's go back to here. Let's get on to number 13. They want us to draw the graph of the quadratic equation whose A is less than 0 with solutions -2, 0, and 6, 0 with a vertex of 2, 5. Okay, so we know that if A is less than 0, it's going to open down. We know our solutions go on those points on the x-axis, and we know our vertex will go on that point. So solutions of -2, 0 6 and 0. Our vertex is 2 and 5. We just need to connect our dots. Yeah, you guys know that's going to drive me crazy. Okay, where is the graph increasing? The graph is increasing on the left-hand side. So from as x is greater than negative infinity, but less than, it stops increasing at 2. So it's got to be less than 2. So up to the vertex. And you could say on the left. Where is it decreasing? It is decreasing over here on the right. So on the right, down from vertex, where x is greater than 2, but less than infinity. Okay, we need to go back now over to our test question for number 13. And they want us to select the correct answer. Function f of x equals negative x squared plus 2x plus 6 is graphed on the xy coordinate plane as shown. It's asking f is increasing on the interval x is greater than 1. So we can look at our question or at our answer choices and see that it's all asking about where is it increasing or where is it decreasing. So just come over here and look. Our vertex is here on 1 and 7. It is increasing. So it's increasing when x is less than 1. It is decreasing when x is greater than 1. So it says over here, f is increasing on the interval x is greater than 1. We already know that's wrong because it's x is less than 1 when it's increasing. Is it increasing on the interval x is less than 0? Yeah. When x is less than 0, it is still increasing here. So that one's correct. F is increasing on the interval x is greater than 3. Well, when x is greater than 3, you can see it is still decreasing, so that is not correct. And f is decreasing on the interval x is greater than 0, but less than 1. So between here and here, they're asking, is it decreasing? No, it's increasing in that little spot. So your correct answer is B. Come back over here, number 14. Let's create a system of equations that is equivalent to 2x plus 5y equals 12 or 3x minus y equals 1. So the easiest way that I'm going to do it is I'm going to get rid of the y's, and I'm going to get rid of the y's by multiplying this bottom equation by 5. So the 2x plus 5y equals 12 is going to stay the same. We're not going to do anything to that. We're going to change the bottom one by multiplying both sides by 5. So we get 15x minus 5y equals 5. That is an equivalent equation, okay? Because all we did was multiply that bottom one, the whole entire thing, by 5. So it says, explain in words how you did this. Well, multiply second equation both sides by 5. We're going to come over here now and we're going to do the same exact thing. Which system of equations has the same solution as the system below? So when I look at this, and I don't even know if it's one of the options, I should look before I say this, and it's not. So I personally would have multiplied the second equation by 3 to get 6x minus 3y equals 15, but that's not one of our choices down here. But that would have also worked. So let's see what they do have. They have 4x minus 2y equals 5. How would they have gotten that? They would have multiplied by 2. But remember, if you multiply the left by 2, you got to multiply the right by 2. And when you do that, you would get 4x minus 2y equals 10. They didn't get that, they got 5. So A is not equivalent. You can cross that out. For B, 3x plus 3y equals 8 stays the same. And then look what they got. 4x minus 2y equals 10. That's what we got. So that one is correct. This one wouldn't work because what they did was they divided x and y both by 3 to get rid of the 3's. They didn't divide 8 by 3. That stayed the same. For this one here, I don't know what they did. Yeah, they multiplied 3x and 3y by 3 to get 9x and 9y. But when they multiplied 8 by 3, somehow they got 22 instead of 24. This one down here, they multiplied both by 9, and that was 9. So the bottom part is correct, but that top one, their multiplication was wrong. So D is not it. Your answer for that is B. Number 15, state 3 synonyms for roots. Okay, so we know roots, zeros, solutions, and X intercepts. Yeah, I don't know why this isn't working. Let's try this again. X intercepts. Hopefully you guys can understand that. I don't know why it's not making that E. X intercepts. It looks like a kindergartner wrote that. Where do you find the roots on the graph? Okay, it is where graph crosses X axis. Write the quadratic equation that has roots of x equals 3 and x equals 6. So if our roots are positive 3 and negative 6, remember our factors are opposite. So it would be x minus 3 and x plus 6. It's the opposite of the roots, okay? Now we can do FOIL to find our quadratic. So x times x is x squared, x times 6 is 6x, negative 3 times x is negative 3x, negative 3 times 6 is negative 18. Combine our like terms, which is the positive 6 and negative 3x, and we get x squared plus 3x minus 18. Select the quadratic that has roots x equals 8 and x equals negative 5. So we do the same thing. If the roots is a positive 8 and a negative 5, then our equation, our factors are x, they're the opposite, x minus 8 and x plus 5. Now we FOIL to get our quadratic. X squared plus 5x minus 8x minus 40. Combine our like terms, we get x squared minus 3x minus 40. There's your quadratic. What did I do wrong? I didn't do anything wrong. Correct answer is right here. Sorry, I saw the 13 and thought it was wrong. So x squared minus 3x minus 40. Your answer for that one is B. Number 16. What does it mean when an ordered pair is a solution to the equation? It is a point on the coordinate plane. So if it is a solution to the equation, it's a point on the graph. It's a point on the coordinate plane. All right, come over here. The following ordered pairs are solutions to linear equations. To a linear equation, negative 20 and 11.5, negative 21 and 12, and negative 22 and 12 and a half. Which of the following graphs shows all of the ordered pairs in the solution set to this linear equation? All right, so as you can see, our graphs don't go up to 20, 21, 22. So we're going to have to figure this out here. So if our x, remember the linear equation is y equals mx plus b, where m is our slope, b is our y-intercept, so if I'm going from negative 20, we're only going to look at the x values right now. Negative 20 to negative 21 to negative 22. We are going left 1, and we're going from 11.5 to 12 to 12 and a half, and we're going up half of a point. So we want to find our graph that goes left 1 and up 1/2, which is actually kind of backwards. If you started on a point, you'd be going down half and right 1. But the way that they have this, it's left 1 up half. So let's look at our graphs. At this one here, I'm going to pick 1 and 0. And then my next point, there's one here on -1 and 3. Does that go left 1, up half? Left 1, up half? Left 1, up half? No, it doesn't. So this is the line where we just put the dots. That's the line that that one would follow. And it doesn't, so it's not C. I don't know why I started on C. B, same thing. Pick 2 points. I got one at 1 and 2. I got one at -1 and 1. Pick either point. Does it go left 1, down half? Up half. Sorry. Left 1, up half. Left 1, up half. We can even left 1, up half. Left 1, up half. No. So you can see the way that that line would go if that was the correct graph, but it's not. Let's look at D. We have a point here on 1 and 3. We have one on -1 and 0. From here, we'll go left 1, down half, left 1, down half, left 1, down half, left 1, down half. You can see that is not the correct line for that one either. So it's got to be A, right? That's why I skipped A. So let's see. We've got 1 and 1, -1 and 2. Do we go left 1, up half, left 1, up half, left 1, up half, left 1, up half? You can see that does follow that line. So your correct answer is A. Oh, wrong one, sorry. Number 17. What does it mean if a quadratic equation has two distinct zeros? Well, that means it has two solutions. Give an example of a quadratic that has two distinct rational zeros. All right, well, let's say x plus 2, x plus 4. When you FOIL that, you get x squared plus 2x. Y'all, this pen is really driving me nuts. Plus 2x plus 4x plus 8. Now we can combine our like terms. You get x squared plus 6x plus 8. So that would have two zeros. Our zeros would be -2 and -4. Those would be our zeros. They're the opposite. Give an example of a quadratic that has exactly one rational zero. Well, how about no, that wouldn't work. Okay, x squared x, oops, x plus 9 squared. X plus 9 squared means x plus 9 times x plus 9. factor that out or FOIL that out, you get x squared plus 9x plus 9x plus 81. Combine your like terms, and you get x squared plus 18x plus 81. Come over here. Number 17. Consider the quadratic equation ax squared plus bx plus c equals 0, where a, b, and c are rational numbers and the quadratic has two distinct zeros. If one zero is rational, which of the following is true of the other zeros? Okay, think back to your rational and irrational rules that we did in problem number 1. When we're talking about distinct zeros, that means, and then it says distinct zeros, just like we had. Say, for example, the one, what did we just do? Hold on. X plus 2 and x plus 4, I think. Two distinct zeros. If one zero is rational, which of the following is true of the other zero? Well, this is foiling, which is multiplication, which is a product. Look back all the way at number 1, which I don't have on here because I did that on a different problem or a different program. But look all the way back at number 1, the product of two rational, or the product. Sorry, hold on. I'm reading. Okay, the product of two rational numbers would always be rational. So if this is saying they are both rational, then the other zero, oh my goodness. Yeah, it's not going to let me fill in that bubble. It's D. The other zero is rational. Number 18 and 20. Okay, so when we go back to the other page, we're going to skip 19 and then we'll go back to it. Okay, because this is for 18 and 20. Write the formula to find the vertex of a quadratic. So to find the vertex, you take the value of b, negative b, and divide it by 2a. You'll get x. Plug x in into the quadratic. To find y. They want us to create our own example and find the vertex. Okay, so x squared minus 4x minus 12. So we take the negative value of b, which our b is already negative, so it's going to become positive. 4 divided by 2 times the value of a, which is 1. So it's just going to be 4 divided by 2, which equals 2. So x is equal to 2. Now take that, plug it back into the quadratic, and solve for y. So we have 2 squared minus 4 times 2 minus 12. 2 squared is 4. Negative 4 times 2 is minus 8 minus 12. 4 minus 8 is minus 4 minus 12. 4 minus 12, sorry, negative 4 minus 12 is negative 16. So x is 2, y is negative 16. That is the point of your vertex. So number 18, what's the vertex of 5x squared plus 20x minus 16? So again, we're going to take negative b divided by 2a. b is 20, so negative 20 divided by 2 times the value of a, which in this case is 5. So it becomes negative 20 divided by 10. You get negative 2. So x is equal to negative 2. Take that negative 2 and plug it in back into the quadratic. So 5 times negative 2 squared. Actually, stop for a second before we do that. We know x is negative 2, so we can come over here and we can eliminate anything that doesn't have x as negative 2. So we can eliminate b. We can eliminate d. All right, so back to this. 5 times negative 2 squared plus 20 times negative 2 minus 16. Negative 2 squared is 4. So it becomes 5 times 4, which is 20, plus 20 times negative 2 is negative 40. So this is 20 minus 40, and then minus 16. 20 minus 40 is negative 20, minus 16. Negative 20 minus 16 is negative 36. So when x is negative 2, y is negative 36. So your answer is C. And then I said we were also going to do number 20. What is the y value of the vertex of 4x squared plus 8x minus 8? Hey, we're going to do the same thing. Negative b divided by 2a. So we get negative 8x, or negative 8, I'm sorry, divided by 2 times the value of a, which is 4. Negative 8 divided by 8 is negative 1. So x is negative 1. I'm going to have to fix this pen when we're done because this is driving me nuts. X is negative 1. Take that negative 1 and plug it back in. 4 times negative 1 squared plus 8 times negative 1. Oops. Minus 8. Negative 1 squared is 1, so that becomes 4 times 1 plus 8 times negative 1 is negative 8 minus 8. 4 times 1 is 4 minus 8 minus 8. 4 minus 8 is negative 4 minus 8. Negative 4 minus 8 is negative 12. Your answer for that one is D. Last one for this video is going to be number 19. They want us to give 3 real-world examples of a quadratic function. So hopefully you guys remember this. A rocket taking off and landing. Jumping from a platform. Sales data Uh-oh. And we'll give one more by saying throwing a ball in the air. What is the shape of a quadratic function? It is called a parabola, which is a U-shaped. Let's go back over here and find number 19. Which of the following situation is a model of a quadratic function? So a tree decays 10% every 6 weeks. That is an exponential, so you can eliminate A. The height of a rocket after it is launched, we just used that as one of our things, so that is a quadratic. A gym charges $15 per fitness class. You take one class, you pay 15, you take two, you get 30, take three, it's 45, take four, it's 60. That's a linear, so that is not C. The height of a diver after stepping from a high dive platform. Okay, here's the high dive platform. He just steps off. So he just goes down. He doesn't jump up and then go down. Okay, so be careful of the wording. I think we talked about this in class, that if he was on a diving board and just fell off, that would be linear. But this says, and that's exactly what that says. It doesn't say jumping up and then back down. So you can eliminate D. So your answer for that one is B. All right, that is all I'm going to do tonight. I will see you on the next one.